Welcome to Brain Vision.
So here in this problem we are given with these two spheres that has mass m, and each of these spheres are connected with this connecting rod that has negligible weight, and the system is rotating about the center of mass. This point is G, center of mass, with the angular velocity of omega, and at the given instant it also have a linear velocity v, as you can see here, that is moving in the positive x-axis. Now we have to determine the angular momentum of the assembly at the given instant about this point O. So the angular momentum about the point O, h naught, will be equals to the angular momentum about point G with respect to O plus angular momentum of the mass A with respect to G, just this point G, plus the angular momentum of the ball B with respect to the point G. So we have to calculate these three terms. Now h G of O is equals to the position vector RG cross the masses are 2m, so 2m times the velocity Vg, and Vg we are given as V. Now let us calculate the position vector first. So position vector Rg is equals to, since the coordinate is x and y, that is given in the equation, so Rg would be xi cap plus yj cap. So we can put the values now. So this is Rg is xi cap plus yj cap, and the cross product with two masses as it is, and Vg we have V, and the vector would be Vi cap because it is along the x-axis. Now we're going to solve this, and by using the determinant method, and we'll get our result to be minus 2 mvy k cap. So this is the angular momentum of the system about point G. Now next I will be calculating HA of G. Now the angular momentum at A relative to point G, HA of G, is equals to the cross product of the position vector R, A of G, and the linear momentum, that is the mass m, and the velocity of A with respect to the point G. Now the position vector RA of G will be equals to, this distance is R, and let this angle be theta. So this angle is theta. So this would be negative cosine theta I cap plus sine theta j cap. Now the velocity of A with respect to G is omega cross R, so RA of G. Now I can put the values here, so this would become omega as it is, and the cross product with this value, so R negative cosine theta I cap plus sine theta j cap. Now I can put the values here, and after putting the values R A of G here and V A of G here and solving it by using the determinant method, we'll get the angular momentum to be m omega r square k cap. Similarly, we can calculate the angular momentum of B with respect to point G, that is h B of G, and this would come out to be as m omega r square k cap. Since the system is symmetric, we can put directly, the value would be same as it is. Now we have obtained this value, and this value. We can plug it here to calculate h naught. So the angular momentum about the point O, h naught, will be equals to So we can put the values. This is negative 2m vy k cap, and this would become 2 times m omega r square k cap. So this is the final answer for the given problem. I hope you have understood the problem. Thank you.